Hi, my name is Harith bin Abdullah, 19001132, and I'm from Electrical Engineering.
Hi, I'm Eim A Perempuan Ewan, 18002254 from Chemical Engineering.
Hi, I'm Aliff Najmi bin Rosli, 18002386 from Chemical Engineering.
I'm Siew Ke Hui, matrix number of 18002431 from Mechanical Engineering.
I am Raziq bin Aznam, 18002308 from Mechanical Engineering. This is a brief explanation about atmospheric water sink. The atmospheric water sink is a machine that is being made to allow people to wash their hands and sterilize their small belongings. The idea behind this project is to promote good hygiene habits among the citizens. The atmospheric water sink are using the concept of atmospheric water generator, which extract water from the humid ambient air as the water source. We also add another feature to our project, which is the UV sterilizer box. The UV sterilizer box will function as a device to sterilize personal belongings such as our handphone, key, wallet and money. Moving on to the problem statement, our team has come out with two problem statements for our project. The first one is low accessibility to hand hygiene facilities. This issue is the reason why people do not always wash their hands. The second problem statement is the increase of risk of eczema and irritated skin from excessive usage of alcohol-based hand sanitizer. For the objective of our project, firstly, we aim to revolutionize access to clean water and better hygiene. The second objective is to produce an alternative sanitization service for the community. For the design thinking tools, it can be separated into 5 parts. The first one is emphasize, where we conduct surveys using Google Form to find out what needs and expectation must be met for our project. Next is define. At this stage, we will analyze the results from our surveys to define a clear problem statement and objectives. Next is ideate. Here we will do a brainstorming to come out with as many ideas and potential solutions as possible. After that, we move to prototype stage. At this stage, we will turn out our ideas into digital prototype using software such as AutoCAD and Fusion 360. Lastly, for the test, we will ask the feedback from our user to make improvement on our prototype. This is the project planning of our team. At this flowchart, it shows every process that we do from the beginning until the end to make sure our project becomes successful. This is the dimension for main body of atmospheric water sink. The atmospheric water sink is 1 meter long, 0.7 meter wide and 0.96 meter tall. The average height of sink at our country is 0.91 meter, and atmospheric water sink is just 5 cm higher than the normal average sink. So this is the final design for atmospheric water sink. It has a faucet which will work with a sensor, a sub-container, a water level indicator, a vent on each side, 2 light indicators, a sink, and a UV sterilizer which use UVC light. At the inside of atmospheric water sink, we have 2 water tanks with a capacity of 40 liter, a sink drain hose, evaporator, expansion valve, condenser and compressor which will be function as the refrigeration system, a water filter, a water pump, and fan on each side at the condenser and evaporator.
Now, we're moving on to the methodology part. For material choices, stainless steel has been chosen for faucet and sink due to its corrosion resistance. Ceramic tiles are used for the top surface due to its hardness, while HDPE is used for the body due to its long last and weather resistance. For the refrigerant cycle, the refrigerant tube is made of aluminum to avoid corrosion. For the water tank and piping system, PVC has been chosen because of its durability. For the filtration system, it is divided into 3 different stages. First, the water will be pumped into the sediment filter where particulates are removed. Then, in the second stages, the carbon filter will remove the inorganic compounds from water. And in the last stages, RO membrane will remove the dissolved inorganic compounds from water before going into the second tank. For the HSE part, the cover will need to be provided for UV light radiation to avoid direct exposure. For the electrical hazard, waterproof system is introduced for the electrical parts in the device.
Our device containing refrigeration cycle, which works in removing heat from low temperature object with heaty refrigeration and rejects it at a higher temperature. There are 4 major parts and components, which are the compressor, condenser, expansion valve, and lastly the evaporator. All these 4 components are connected together through connecting pipes to construct a complete basic refrigeration cycle. This cycle can be divided into 2 parts, which is the low pressure side on our left and the high pressure side on our right. The refrigerant, which is also known as the coolant, will flow through all the components in the pipes. First, let's start with the compressor, which compresses the low pressure vapor refrigerant inside the compressor chamber. According to Gay-Lussac's law, the pressure of a given amount of volume is directly proportional to the temperature. So when the refrigerant is compressed by squeezing the vapor tightly together into high pressure, it will simultaneously increase the temperature. After that, it will leave the compressor and enter the cold condenser. According to the second law of thermodynamics, heat will flow spontaneously from a hotter body to a colder body. So when the hot refrigerant vapor enters the condenser, it will start releasing heat to the surrounding, and at the same time, it condenses from vapor form into liquid form. A fan is installed to liberate the latent heat past the condenser coil to prevent it from overheating and ensure the process of condensation. Now, the refrigerant will enter the expansion valve, which helps in removing pressure from liquid refrigerant to allow expansion, causing a change in state where it changes from liquid to saturated mixture which containing liquid and vapor, which is in cool and chill state. It will then enter the evaporator. The low temperature and pressure refrigerant in the coil will start absorbing heat from the surrounding. A fan is installed to circulate and draw the warm air into the enclosed space and blow across the coil in the evaporator that carrying cold, chill saturated mixture refrigerant. This causing the effect of condensation, and this is where we collect our water.
Now, I'll proceed the presentation by explaining the process of water flow.
Can we turn atmospheric air into clean and usable water? Let's go through the process of water flow for atmospheric water sink. Firstly, we should understand that even in the dryers, the humidity level is never zero. Hence, some amount of water is present. The energy source for running this AWS is electricity, which will move the fan and increase the airflow rate. The humid air sticks to the evaporator to perform heat exchange. By heat exchange, air is then cooled down below its dew point and condensed into water, and precious drops of water is stored into the water tank. The collected water in the tank will pass through the water filter to remove impurities, including the dirt, to produce clean and usable water for daily usage. The clean water produced can be used for hand washing, and it is also drinkable. Here is the overall view of the process of water flow of AWS.
Let's move on to the simulation. The circuitry was designed to eliminate the possibility of overflow and lack of water by using sensors. When the water in the tank is below 25%, the motor of the fan will increase and more power is applied to the compressor. While if the water is above 85%, it will be considered as overflow and the fan will immediately stop, followed by a shutdown at the compressor. We also add in a water level indicator to represent the amount of water in the tank. We calculated the capital cost to be 1,250 ringgit due to the usage of filters making the water drinkable. We compared it with the price of drinkable water with the same amount of liter produced by the machine. So in a year, the return investment of this product can be estimated to 80% to the price of the machine. As we know, higher ROI represents a successful investment. Of course, there are operational costs to take note of, such as the system development and maintenance. With an estimate of 1,000 ringgit a year, this is included with the change of 3 filters every month. Moving on to the feedback from the users, it is seen that many have agreed with our objective, our design and our working principles. Not to mention, we asked them if our product follows the 4 SDGs, and surprisingly, a majority agreed to it. So let's summarize what we have learned today. Our product, which is AWS, takes in humidity from the air and condenses it to water at the evaporator. And this condensation is due to heat exchange by the refrigeration cycle. The water in the tank will then flow into a 3-phase filter to make the water clean and drinkable. Moving on to our second objective, we added in a UV sterilizer box as an alternative sterilization service for the user to disinfect their pocket items. In terms of cost, material and design, we can apply this machine anywhere as long as there is a roof and a power outlet at that area. We do have a few recommendations to the product, such as connecting a direct piping to the main line. This can solve the limited amount of water produced in a day. Furthermore, using solar panels as a source of energy rather than using direct power line, this will further encourage SDG 12 into our product, which is responsible for consumption and production. And finally, create a mobile application that can detect when the product requires maintenance. We do hope you enjoyed the presentation.
Thank you
and
and
stay
stay hygienic.